Today, we're exploring the future of work, specifically, how robots are stepping into industries you had never expect. From creative fields to hands-on trades, automation is shaking things up in surprising ways. Get ready, this is going to be an exciting journey into the robotic revolution. Picture this, a world where robots aren't just assembling cars or sorting packages, they're crafting art, teaching kids, or even helping therapists. Sounds like sci-fi, right? Well, it's happening now. In this video, we'll uncover the unlikely industries where robots are making waves and how they're redefining the way we work. Automation used to be all about factories and repetitive tasks. But today, robots are smarter, more adaptable, and powered by AI that's pushing boundaries. Industries once thought untouchable, like education, healthcare, and even creative arts, are now seeing robotic integration. So, what does this mean for the future of jobs? Let's dive into 3 surprising examples. First up, education. Robots are stepping into classrooms, not to replace teachers, but to enhance learning. Picture robotic tutors that personalize lessons for each student, using AI to adapt to their pace and style. In Japan, robots like Pepper are already assisting in language classes, engaging kids with interactive games. And in special education, robots are helping kids with autism practice social skills in a low-pressure way. The result? Teachers get more time to focus on creativity and mentorship, while students get tailored support. It's a win-win. Next, let's talk about the arts. Yes, the arts. Robots are painting, composing music, and even writing scripts. AI-driven robots like AIVA are creating symphonies, while others are collaborating with artists to produce stunning visual pieces. In advertising, robots are generating ad copy and designing visuals faster than ever. But here's the kicker. These robots aren't replacing human creativity, they're amplifying it, giving artists tools to push their work to new heights. Who knew robots could have an artistic side?
Meet Aida, the groundbreaking ultra-realistic artist robot. With her camera eyes, AI algorithms, and robotic arm, she creates mesmerizing artworks and captivates audiences as a performance artist, designer, and poet since her debut in February 2019. From prestigious exhibitions like the United Nations AI for Good Global Initiative to forums at the House of Lords and the Oxford Union, Aida stimulates discussions on the implications of emerging technologies. Her influence transcends borders, sparking vital dialogues about responsible tech use, inspired by data and continuously challenging artistic norms. Aida offers the option to be presented standing or seated. Despite having legs, she is incapable of walking. Equipped with cameras in her eyes, Aida can establish eye contact and, with the aid of a computer vision algorithm and a modified robotic arm, produce sketches based on her surroundings. Meet Arto 1, the drawing robot developed by Naver Labs, which learns from human interaction to wield a brush with precision. Featuring interactive haptic technology for accurate force control, Arto 1 integrates a cloud-based AI that processes a vast array of movements. By assimilating user preferences and techniques, Arto 1 autonomously adjusts its strokes based on variables such as force, speed, and angle, making informed artistic decisions. Arto 1 utilizes advanced haptic technology to precisely manage force, while its cloud computing infrastructure orchestrates thousands of motion possibilities through sophisticated hardware manipulation. Operating on an iPad as its digital canvas, Arto 1 employs a manipulator capable of torque control across 4 degrees of freedom. In another innovation, Japanese researchers from Cross have developed Hexa, a 6-legged spider robot equipped with capabilities to navigate stairs, operate in low light, and discern colors. Controlled via smartphone, Hexa stands 15 cm tall with a 40 cm diameter, featuring Wi-Fi connectivity, a camera, and sensors for autonomous movement. Despite a 4-hour battery life, developers plan to release Hexa for public purchase soon, with programming options allowing tasks such as indoor plant care, available for $950 on the official Hexa website. Hexa utilizes a drawing pen to craft meticulous sketches that showcase artistic expression in program designs and real-time inputs. In March 2021, we stumbled upon a YouTube video featuring the artistic robot Russolino. This little robot specializes in painting watercolors and was showcased at the Maker Faire in Rome. Using its attached arm, Russolino skillfully created a painting of a cat. The robot utilizes a GRBLESP32 controller and can draw on a specially designed board. Frida, an AI-driven robot developed at Carnegie Mellon University, translates your prompts into physical paintings using bold brushstrokes and various techniques. Named after the Framework and Robotics Initiative for Developing Arts, Frida is essentially a robotic arm equipped with a paintbrush. Despite sharing its name with the renowned Mexican painter Frida Kahlo, the team emphasizes that Frida is a robotic painting system rather than an artist. However, it can adjust its course while painting to emulate the iterative nature of artistic creation. In contrast to AI art tools such as DALL-E and Stable Diffusion, which transform short text prompts into digital art, Frida can be seen as a more unconventional AI art generator. Developed in 2021, Ameca represents an advanced humanoid robot designed to pioneer future robotic technologies. Equipped with microphones, cameras, and facial recognition software, Ameca offers both GPT-4 capabilities and human telepresence for interactions. It features articulated motorized arms, fingers, neck, and presents a gender-neutral appearance. In June 2023, Engineered Arts demonstrated Ameca's newfound ability to create drawings using Stable Diffusion technology, which enables the robot to imagine and produce artwork. In the YouTube video, Ameca is tasked with creating a drawing of a cat. Despite the challenge of converting images into vectors and lines, the emphasis stays on producing rapid and engaging sketches. Ameca consistently signs its artwork once finished. Acrylic is a pioneering art tech startup dedicated to facilitating artists in earning a livelihood by selling their work at affordable prices. Employing robotics and machine learning, Acrylic enables artists to teach intelligent robots to recreate their brushstrokes using actual paint on canvas. This innovative approach empowers artists to market limited edition collections of NFT-authenticated artwork, conceptualized by them and painted by their robotic counterparts at a large scale.
Now, here's where it gets really wild. Therapy. Robots are entering mental health spaces, offering support in ways humans can't always match. Take Ellie, a robotic therapist developed by USC. It uses AI to analyze facial expressions and tone, helping patients open up about tough topics. These robots are being used in teletherapy, veteran care, and even elderly companionship. The Trexo treadmill is an innovative accessory designed by Trexo Robotics to enable indoor gait training for children with disabilities, allowing the robotic exoskeleton to operate in compact spaces without navigating outdoor obstacles. It promotes consistent daily walking sessions by providing a stable, level surface for fine-tuning gait patterns and building strength, reducing the risk of missed therapy due to weather or space constraints. Compatible with the Trexo home device, it supports family workouts alongside the child and tucks neatly away, making rehabilitation accessible and engaging in everyday home environments. Fourier Intelligence has developed the Fourier GR1, a robot designed to assist as a physiotherapist. Currently operated by a human, its autonomous AI is still in development. In the future, GR1 will help with tasks like getting into bed or transferring to a wheelchair, particularly for immobilized patients. The robot can walk, maintain balance, and perform tasks such as sitting, standing, jumping, using utensils, and operating tools. These abilities make GR1 suitable for home assistance, rehabilitation, and companionship for the elderly. Standing 165 centimeters tall and weighing 121 pounds, GR1 features 40 FSC joints, offering 44 degrees of freedom, and has a walking speed of 3 miles per hour. It can lift up to 110 pounds, navigate obstacles, and assist with physical therapy. Fourier Intelligence plans to produce 100 units by the end of 2023 for road labs. Equipped with depth cameras for real-time perception and an adaptable gripper, GR1 can safely handle various objects. It also integrates fleet management software, enabling centralized control of multiple robots. GR1 is versatile, suited for research, healthcare, rehabilitation, education, and more. Dr. Alfred, a hyper-realistic robotic surgeon developed by Engineered Arts, recently debuted in Dubai. Dressed like a real doctor, he combines lifelike appearance with advanced AI and voice recognition, allowing him to hold natural conversations, answer personal questions, and understand multiple languages and accents. While he hasn't performed any surgeries yet, Alfred showcases the potential for humanoid robots in healthcare, tourism, and hospitality. With his ability to interact fluently and even joke around, he could one day serve as a hotel receptionist or tour guide. Grace, a humanoid robot developed by Hanson Robotics and sister to Sophia, is designed to assist in healthcare, especially for the elderly and those with degenerative brain diseases. Her role became especially important during the COVID-19 pandemic, offering companionship to isolated patients. Fluent in English, Mandarin, and Cantonese, Grace uses AI to support medical diagnoses and interact with patients. She wears a blue nurse's uniform and features a thermal camera in her chest to monitor temperature and pulse without direct contact. Her goal isn't to replace healthcare workers, but to support them, improving efficiency, reducing loneliness, and promoting mental well-being through conversation and guided activities. Robotic surgery has revolutionized patient care, enabling advanced, minimally invasive procedures with unmatched precision. These technologies reduce surgical tremors, enhance 3D visualization, and offer improved ergonomics for surgeons. For patients, the benefits are substantial: less blood loss, quicker healing, reduced postoperative pain, and faster recoveries. As robotic systems evolve, they continue to elevate the standards of surgical care, making operations safer and allowing patients to return to daily life more swiftly than ever before. A major milestone in this field was recently achieved by Groote Schuur Hospital in Cape Town, South Africa, which became the first state hospital in Africa to perform robotic-assisted surgery. This was made possible through the introduction of the Da Vinci She surgical robot. With its articulated arms and advanced maneuverability, capable of nearly 360-degree movement, the robot allows surgeons to perform complex procedures with greater precision and in shorter time frames. Dr. Sam Cahill Selakazana, the hospital's robotic surgery coordinator, emphasized the robot's ability to surpass traditional laparoscopy in both vision magnification and anatomical clarity, simplifying even intricate dissections. Engineers from Intuitive Surgical, an American company, have developed one of the most advanced medical robots, Da Vinci 11. This cutting-edge system is designed to perform complex surgical procedures with minimal intervention, offering precision, control, and flexibility that far exceed traditional methods. Equipped with multiple mechanical manipulators, Da Vinci 11 precisely replicates a surgeon's movements, providing enhanced accuracy and eliminating hand tremors. The system facilitates minimally invasive surgeries through tiny incisions, significantly reducing blood loss, minimizing the risk of complications, and accelerating patient recovery. Its wrist instruments offer more maneuverability than the human hand, while tremor filtration and intuitive movement technologies ensure smooth and precise operations. The price of this advanced robot is $1.9 million. In the near future, robots will be capable of fully replacing medical personnel, performing both routine and complex tasks with ease. One of the most advanced solutions in this area is Yumi, a mobile and autonomous medical robot designed to work alongside doctors and laboratory staff. Featuring a dual-arm design with 14 axes of movement, Yumi offers exceptional maneuverability and precision. This advanced design enables it to carry out delicate procedures such as liquid dispensing, sorting test tubes, and handling laboratory equipment. Equipped with a machine vision system, Yumi can identify objects, analyze their positions, and manipulate them with great care, minimizing the risk of damage. Yumi can also be programmed to handle repetitive tasks such as automatically opening test tubes, loading centrifuges, and sorting medical samples, thus easing the workload of staff and speeding up analysis and processing times. Globally, robotic innovations are reshaping medical procedures. In September 2017, Xi'an City in China's Shaanxi province witnessed the debut of the world's first autonomous dental implant robot. Developed locally, this advanced system combines mechanical space fusion positioning with 3D printing integration. Before surgery, patients receive a CT scan to capture detailed data on the skull and jaw, which the robot uses to guide its arm with high precision during implant placement. In under an hour, the robot successfully installed 2 implants with an accuracy margin of just 0.2 to 0.3 millimeters, significantly surpassing manual techniques. Professor Joey Mean of the 4th Military Medical University praised the achievement as a transformative moment in dental surgery and a testament to China's leadership in precision healthcare. In another breakthrough, surgeons at Vall d'Hebron Hospital in Barcelona, Spain, performed the world's first robotic lung transplant. Unlike conventional methods that require large incisions in the chest, the robotic system allowed for smaller, minimally invasive openings between the ribs. Using its 3D cameras and mechanical arms, the robot inserted a deflated lung with remarkable precision. The patient, Xavier, 65, reported waking from surgery pain-free. This pioneering approach offers the potential for quicker recovery and improved post-surgical outcomes. Robotic integration has also transformed treatments for kidney stones, which are prevalent in countries like Italy, Greece, and Iran. While smaller stones may pass naturally, larger ones can obstruct the kidneys and lead to inflammation. Traditional surgical methods have been largely replaced by laser-based, non-invasive techniques pioneered over the past 15 years by Turkish scientists at Avicenna Hospital. These procedures involve pulverizing kidney stones through the urinary tract using lasers, then extracting the debris with flexible tools. When paired with robotic systems, these tools offer unparalleled precision in navigating kidney cavities and ensuring complete stone removal. Iran, in response to international sanctions that blocked access to the US-made Da Vinci surgical system, began developing its own robotic surgery technology in 2006. The result is a sophisticated robot capable of performing abdominal, pelvic, and thoracic surgeries, operated remotely via a 5G network. Surgeons control the robot from a master console, with movements transmitted in real time. Notably, the Iranian system has proven its reliability and performance, most impressively during a high-profile surgery on a female tiger in Indonesia, performed remotely over a stable internet connection between hospitals. Experts note that Iran's technological progress in medical robotics is a direct result of overcoming economic barriers, which have driven innovation and self-reliance in the healthcare sector. These global advancements collectively signal a new era in robotic surgery, one defined by precision, accessibility, and transformative patient outcomes across borders and specialties. Meet the LBR Med, KUKA's game-changing lightweight robot, designed specifically for the medical world. This isn't just any robot. The LBR Med is a highly sensitive, intelligent robotic component built to seamlessly integrate into medical products. It's tailor-made to meet the toughest standards in medical treatment and surgical interventions, featuring biocompatible, corrosion-resistant surfaces that are ready for clinical environments. And here's the best part, with KUKA's CB certificate and CB report, you're cutting down on complex post-delivery testing, making certification faster, easier, and way less stressful. Baptist Health Fort Smith has introduced a new advanced tool for early lung cancer detection called the Ionic Robotic Bronchoscopy System. This technology allows doctors to locate and biopsy small, hard-to-reach lung nodules with high precision using a GPS-like system guided by CT scans. The procedure is minimally invasive and done on the same day, reducing travel and wait times for patients. Dr. Muthu Kumar Radhakrishnan highlights its potential to improve prognosis and expand treatment options. This innovation reflects the hospital's commitment to improving patient care and local access to advanced diagnostics. Rubio is a bipedal humanoid robot designed to support elderly and disabled individuals with daily tasks. Featuring retractable legs for compact navigation, Rubio assists with lifting, transferring, and walking, reducing physical strain on both caregivers and patients. Its advanced sensors help prevent accidents, detect obstacles, and monitor vital signs, enhancing overall safety. Additionally, Rubio is equipped with a tablet interface to facilitate communication, offering emotional support and companionship to combat loneliness and social isolation. Researchers at the University of Sheffield have developed the Robotic System Medical, a cutting-edge device designed to provide medical assistance in combat zones and other hazardous environments. This innovative robot is equipped with two manipulators that enable remote measurement of vital signs, including temperature, blood pressure, heart rate, and even abdominal palpation. The system is controlled through virtual reality, allowing medical specialists to examine and treat patients from a safe distance using VR headsets. In emergency situations, the robot can transmit photos and videos of injuries to train medical personnel and facilitate remote observations, such as monitoring a patient's temperature and blood pressure. The robot is specifically designed to operate in environments with radioactive contamination, biological hazards, and active combat zones. The increasing demand for healthcare professionals, driven by aging populations and ongoing labor shortages, continues to place significant strain on hospitals worldwide. Humanoid robots, with their human-like dexterity and adaptability, present a promising avenue to help alleviate these pressures by supporting clinical procedures. In a video published by the UCSD Advanced Robotics and Controls Lab on March 18, 2025, researchers showcased an exploratory study on the use of humanoid robots for direct patient care via teleoperation. The team developed a bimanual teleoperation system for the Unitree G1 humanoid robot, integrating high-fidelity pose tracking, customized grasp configurations, and an impedance controller to ensure safe and precise manipulation of medical instruments. The system was tested across 7 diverse medical procedures, including physical examinations, emergency interventions, and fine motor tasks such as ultrasound-guided needle insertions. Results demonstrated that humanoid robots can effectively replicate essential aspects of human medical assessments and interventions, showing particularly strong performance in ventilation and ultrasound-guided tasks. Despite the encouraging outcomes, notable limitations remain. The robot's restricted force output limits its effectiveness in strength-intensive procedures, and current sensor sensitivity affects clinical precision. Nevertheless, this research highlights the growing potential of humanoid robots in healthcare settings and lays important groundwork for future advancements in robotic integration within hospitals. At CES 2023 in Las Vegas, Ulyss Robotics unveiled EO, a dual-armed humanoid robot designed to revolutionize a wide range of service tasks, including delivery, security, elder care, kiosk operations, and UV germicidal disinfection. The robot's impressive mobility and advanced capabilities allow it to effortlessly perform tasks such as opening doors, manipulating objects, and navigating elevators. ADIO, as it's also known, combines versatile mobility with practical functionality, making it ideal for real-world environments in fields like delivery, elder care, and security. Available both as a standalone robot and a service platform, ADIO supports plug-and-play attachments and integrates seamlessly with third-party developers, including Aceri Tech from Japan and Malabu AI from Taiwan. Equipped with dual arms featuring 7 degrees of freedom, ADIO can perform tasks like delivery or disinfection with one arm, while the other manages mobility functions such as operating elevators and handling doors. With Ulyss's third-generation arms capable of lifting up to 8 pounds with a single arm, ADIO is equipped with advanced vision algorithms. These enable diverse functionalities, such as monitoring the posture and position of elderly residents for safety, as well as enhancing security by detecting open windows or misplaced items like backpacks. Students at GLISSON International Academy in Abuja, Nigeria, have created a versatile robot designed to assist in the remote treatment of COVID-19 patients and potentially other infectious diseases. Named My Robot, it is capable of dispensing medications, monitoring temperatures, and facilitating webcam-based communication between patients and healthcare providers. While it currently faces challenges with tasks such as opening doors, the robot has received support from healthcare professionals due to its potential to minimize contact time between medical staff and patients. Teacher David, who supervises the robotics team, is optimistic about future improvements to meet international standards and eventually achieve commercial viability. Meanwhile, Moxie, an autonomous delivery robot developed by Diligent Robotics in Austin, Texas, is actively supporting medical staff at Edward Hospital in Naperville. Using pre-programmed digital maps and advanced sensors for navigation, Moxie autonomously delivers medical supplies, prescriptions, and lab samples. It can also dock itself for recharging, ensuring continuous operation. By handling routine deliveries, Moxie enables nurses and doctors to dedicate more time to patient care. Its integration has significantly improved task efficiency, with plans underway to expand its use in additional hospitals, highlighting the growing role of robotics in enhancing healthcare support systems. In Thai hospitals, scenes of overworked doctors and nurses rushing between patients, who wait for hours, highlight the persistent challenge of nurse shortages. To help address this, Munk Wat Anna Hospital in Bangkok has introduced nurse robots, Nan, Nim, and Li, from China. These robots navigate the hospital using magnetic strips, assisting with tasks such as managing paperwork, dispensing medications, and even comforting patients by singing. While they enhance efficiency and reduce the risk of errors, hospital officials emphasize that the robots are designed to support, not replace, human staff. Nursing remains a deeply human profession, especially for sensitive procedures like tube insertions and injections. Dr. Noonan, director of motherhood at Watana Hospital, expressed satisfaction with how the robots ease the workload and elevate patient care, while preserving the essential role of human caregivers. Researchers at Climate Scientific have created a one-of-a-kind training robot for healthcare professionals. His name is Hal, and he looks and acts just like a 5-year-old boy. Hal is built to help doctors and nurses practice using real medical tools and techniques in a lifelike, yet safe environment. He can follow your finger with his eyes, answer questions, cry, call for his mom, and even simulate serious conditions like anaphylactic shock. He shows fear by breathing fast or wetting himself, and students can practice real procedures like checking his pulse, measuring blood pressure, or performing intubation. He can even be shocked with a defibrillator, and flinches or says ouch during injections. While Hal acts like a real child, his design avoids ultra-realistic details like freckles or tiny hairs. Why? To help students focus and reduce emotional stress, especially during high-intensity scenarios like cardiac arrest. Pediatric Hal, developed by Gomert, is part of a wider family of high-tech simulation robots, including models for pregnancy, newborn care, and trauma. All designed to give medical students hands-on experience before working with real patients. Peter Ackroyd is an advanced pediatric patient robot designed to authentically simulate the behaviors of children, including hesitant movements when reluctant to undergo treatment and sudden shifts in medical condition. Created to address the gap in clinical training involving pediatric care, this robot meticulously replicates emotional expressions such as joy, anger, sorrow, and sadness, along with realistic changes in facial color, pupil dilation, and breathing sounds. Though primarily used for dental procedures, the system is highly versatile and applicable to various pediatric medical fields, including emergency care. Its capabilities include full-body movements to resist dental treatments, spontaneous actions like head shaking, sneezing, coughing, and simulated vomiting in response to pain. Additionally, the robot mimics dynamic physiological changes, such as pulse variations, respiratory patterns, and complexion shifts during treatment. The Peter Ackroyd system also engages in conversational speech, facilitates tooth model cutting, and supports simulations for intravenous injections, cardiac massage on the hands and back, as well as nail bed compression tests.
Meet Poro, a cute robotic seal designed to provide emotional comfort. It responds to touch and voice, helping reduce stress and loneliness for seniors, especially those with dementia. Loneliness affects over 40% of aged care residents daily. Abby, a bright, childlike humanoid robot, was created to address this issue by providing companionship, emotional connection, and meaningful interaction. Standing at 110 centimeters, Abby is equipped with facial recognition, omnidirectional microphones, multilingual capabilities, and memory storage, enabling her to personalize conversations and engage naturally with residents. Her lifelike expressions and engaging personality help build trust and emotional bonds, improving residents' mood and participation in activities. Abby also leads group exercises like Tai Chi and dancing, often inspiring residents to move and interact more, which can be deeply moving for staff to witness. While currently focused on aged care and healthcare, Abby's potential spans many industries. She represents a new approach to supporting vulnerable populations, and her impact is just beginning. Wondercraft, a French company, has introduced Calvin 40, a headless humanoid robot with a bold, functional design that breaks away from traditional human-like appearances. Unlike American counterparts such as those from Boston Dynamics, Calvin 40 emphasizes performance over form, sparking global interest in its originality. As France's first industrial humanoid robot, Calvin 40 was developed in just 40 days. Thanks to Wondercraft's earlier work on a medical exoskeleton called EV, designed for people with mobility issues. This allowed the company to repurpose existing technology, saving both time and resources. Calvin 40 operates autonomously, responding to voice commands and making real-time decisions within its programming. Although real-world demonstrations are still pending, the robot shows promise in pushing intelligent robotics forward. Its vision system, unusually placed at the center of its body, provides a stable, unobstructed field of view, ideal for industrial environments. Combined with day and night cameras and the absence of costly LiDAR systems, it can effectively navigate and identify objects. The robot's feet are equipped with 4 sensors for balance and mobility, and it has walked over 1 million steps in testing. LED indicators display its status, enhancing safety during human interaction. Designed for flexibility, Calvin 40 features swappable hands for various tasks in manufacturing, healthcare, and caregiving. Next, there's Pepper, a humanoid robot that can recognize emotions, hold conversations, and even guide seniors through exercises. It's like having a friendly assistant at home. And don't forget Robotic, a bear-like robot from Japan that helps with lifting and moving seniors, reducing strain on caregivers. In Hangzhou, China, a 4-legged robot dog named Shocky is helping care for the elderly. Equipped with a medical kit, Shocky reminds residents to take their medication, provides companionship on walks, and assists them in finding the bathroom. It's quickly become a trusted and friendly caregiver in the community. Another robot stepping up to help is Quavo. It's currently being trained to handle everyday tasks like delivering water, meals, and medication. Weighing around 45 kilograms, Quavo is designed for home and family use. It can do chores like washing and drying clothes, watering plants, and even arranging flowers, making it a helpful little assistant for daily household care. Meet Xia Lan, a humanoid robot who's become a friendly companion to many elderly residents. With lifelike skin, blinking eyes, and a warm, soothing voice, Xia Lan feels surprisingly human. She can even chat with seniors, offering simple conversations and helpful services, like giving weather updates. It's just one more way robots are bringing comfort and connection to elder care.
你知道现在是什么天气啦？是什么季节啦？让我查一下，今天的天气是晴天。
They're not here to replace therapists, but to make mental health support more accessible, especially in underserved areas. Several companies are leading the way in developing humanoid robots that are transforming industries. From mobile production assistants like Aptronic's Apollo to the adaptable, AI-powered Isaac Groot N1, these robots are revolutionizing manufacturing and beyond. As the race to integrate these robots into real-world tasks intensifies, the future of work and automation is looking increasingly human-like. The time has finally come when Boston Dynamics robots, typically known for their impressive dances and stunts, are starting to make their mark in real-world industrial applications. The latest advancement with the Atlas robot, capable of unpacking and moving automotive plates, could be a game-changer for its future. The automotive manufacturing sector, where precision, reliability, and the ability to handle heavy components are essential, seems like the perfect environment for humanoid robots. While specialized industrial robots have already found widespread use in this field, complex tasks that require human-like dexterity and decision-making have remained out of reach. Elon Musk has already signaled his plans to deploy Tesla Optimus robots at Tesla factories, and the startup figure aims to test its robots in BMW production lines. Now, Boston Dynamics, under the ownership of Hyundai, is poised to contribute by offering its Atlas robot to the automotive manufacturing industry. Though still an experimental project, Atlas shows tremendous promise as a humanoid robot, and its potential commercial use could represent a significant milestone in robotics, validating years of academic research and innovation. Boston Dynamics Atlas is a true marvel of engineering, designed for peak mobility and precision. Powered by electricity and equipped with an advanced hydraulic system, Atlas can perform incredible, agile movements. We're talking running, jumping, and even backflips. Whether navigating dangerous terrain or handling delicate tasks, Atlas is paving the way for humanoid robots to become a part of our daily lives. Let's turn our attention to BMW's production facilities, where the company has signed a commercial agreement with the robotics startup Figure. As promised, Figure is delivering on its commitment to quickly deploy its android robots to perform real, practical tasks at BMW's Spartanburg plant under the newly established deal. Figure has begun identifying initial use cases and is training its robots for phased deployment at the site. Brett Adcock, the founder and CEO of Figure, highlighted that automakers have amassed extensive experience in robotics, especially in the realm of humanoid robots. Companies like Honda with Asimo, Tesla with Optimus, Hyundai with Boston Dynamics, and the Toyota Robotics Institute have all worked with humanoids, though their focus has generally been on specific tasks rather than general-purpose applications. BMW has already integrated a significant amount of robotics at its Spartanburg plant, but the automaker is seeking to tackle new automation challenges with more agile, mobile robots. Training for the first tasks that Figure's robots will perform at BMW has already started in Figure's labs. While the exact roles of these androids in the factory haven't been publicly revealed, the deployment will begin with a small batch of robots. The full integration of these robots into BMW's production processes is expected to take anywhere from 12 to 24 months. The American company Figure AI has released a new video showcasing the progress of integrating its humanoid robot, Figure 02, into BMW facilities. The video highlights how the robot now performs a range of automotive manufacturing tasks with greater speed and precision. Standing at 168 centimeters tall and weighing 70 kilograms, Figure 02 is equipped with 5 fingers on each hand, offering 16 degrees of freedom, which enables it to handle objects weighing up to 25 kilograms. The robot is outfitted with 6 RGB cameras and integrates a language-based visual perception model, allowing it to navigate and interact with its environment with impressive accuracy. Additionally, a custom AI model, developed in partnership with OpenAI, enables the robot to understand and follow natural language commands while also engaging in conversations with humans. Figure AI's collaboration with BMW began in January 2024, with the shared goal of introducing humanoid robots into automotive production. In August 2024, Figure 02 was deployed at BMW's South Carolina plant, where it successfully carried out tasks like precisely placing metal components into assembly fixtures. This collaboration with BMW underscores the immense potential of humanoid robots to enhance manufacturing efficiency and precision. Amid the surge of startups racing to develop a universal robot, Bill Gates recently shared his personal top 5 projects in this field. Leading the list is Agility Robotics, which has already sent its robots for testing at Amazon and is now gearing up to scale production to 10,000 units per year. Taking second place is the Tevel project, which focuses on non-humanoid robots. While the concept might seem unusual at first, it has proven to be quite viable. These robots are already operating in gardens across Italy, the US, Israel, and other countries. In third place is Aptronix, with its humanoid robot Apollo, which is set to be available for purchase later this year. This general-purpose robot can be programmed for a wide range of tasks, from logistics and manufacturing to household chores. However, Gates points out that programming individual tasks for each new job is cumbersome, and that companies like Figure and the Toyota Research Institute are advancing more effective methods of teaching robots through demonstration. Next, in fourth place, is the Robotics and Mechanisms Laboratory at the University of California, Romela. This lab is not limited to humanoid robots but also develops a variety of alternative robot forms. While it's not a startup, its innovative work continues to show great promise. Finally, rounding out Gates's list at number 5 is Field AI, a company creating autonomous systems for robots of all shapes and sizes. These systems allow robots to navigate streets and adapt to unpredictable environments, making them well-suited for a variety of real-world applications. Agility Robotics, Digit, is a cutting-edge mobile manipulation robot, MMR, designed for seamless integration into existing workflows. Standing at 5 feet 9 inches and capable of carrying up to 35 pounds, Digit is a powerhouse for tasks in warehousing, distribution, and manufacturing environments. What sets Digit apart is its bipedal design, which allows it to navigate complex environments, including stairs and tight spaces. Its safety-focused design meets industry standards, and its flexibility makes it ideal for industrial applications, whether as a robot as a service, RaaS, or through a capital expenditure, CapEx, acquisition. Equipped with specialized end effectors and advanced perception capabilities, Digit is optimized for tasks like tote handling. Its unique leg design, with human-like backward knees, allows it to reach shelves up to 6 feet high and work efficiently in tight spaces. It's a versatile, safe, and efficient solution for modern industrial environments. Equipped with specialized end effectors and advanced perception capabilities, Digit is optimized for tasks like tote handling. Its unique leg design, with human-like backward knees, allows it to reach shelves up to 6 feet high and work efficiently in tight spaces. It's a versatile, safe, and efficient solution for modern industrial environments. Mercedes-Benz has started the mass deployment of humanoid robots at its Berlin factory. The Marienfelder plant, home to the Mercedes-Benz Digital Factory campus since 2022, serves as a hub for the company's innovations, where new technologies are tested before being rolled out to other facilities. Now, the company is taking a major step forward by introducing humanoid robots named Apollo, developed by the American company Aptronix, into the production process. Unlike traditional stationary industrial robots that perform repetitive tasks in one fixed spot, Apollo robots are mobile and can navigate freely across production areas to handle a variety of tasks, helping to accelerate manufacturing processes. Currently, they're being tested in logistics, component transportation, and quality inspection. With the use of augmented reality and remote control, the robots are trained to function in real-world manufacturing environments. Looking ahead, Apollo robots will operate autonomously, marking a significant leap in the development of flexible robotic systems. Aptronix Apollo stands 1.73 meters tall and weighs 72.6 kilograms. Apollo is designed to operate for up to 4 hours on a single battery charge, making it suitable for a wide range of human-like tasks. With the ability to carry up to 25 kilograms, Apollo is perfect for both lifting and transporting heavy items in industrial settings, as well as handling lighter, more delicate tasks in environments like elder care or hospitality. Its humanoid design and endurance allow it to work efficiently in human-centric environments, making it a valuable asset for warehouses, logistics, and service roles. Apollo's versatility makes it a prime candidate for transforming industries that rely on both human dexterity and persistence, offering a glimpse into the future of robots in the workforce. On December 19, 2024, Aptronix, the AI-driven humanoid robotics company, announced a strategic partnership with the Google DeepMind robotics team. This collaboration aims to combine leading-edge artificial intelligence with state-of-the-art hardware and embodied intelligence, pushing the development of humanoid robots that are more capable and adaptable in dynamic, real-world environments. Westwood Robotics has unveiled an updated version of its full-sized humanoid robot, Themis version 2. This new model incorporates cutting-edge technologies and innovative solutions designed to improve human-robot interaction across various industries. The previous version of Themis was already capable of walking at human-like speeds and running up to 10 kilometers per hour. Themis version 2 takes things further, with the ability to perform complex dynamic movements, including parkour, an impressive milestone in humanoid robotics, made possible by advanced sensors and control systems. The robot is built to ensure safe interaction with both its environment and people, a critical feature for tasks in shared spaces. Designed to tackle a broad range of duties across sectors like manufacturing, healthcare, and services, Themis excels in executing precise and dynamic movements while maintaining safety. Its ability to adapt and perform flexible tasks makes it an ideal candidate for automating processes that demand high levels of agility and precision. The New York Police Department has begun rolling out Daiji Dog robotic dogs for city patrols. Mayor Eric Adams believes that technology is crucial for maintaining public safety, and as part of this vision, Daiji Dog robots, developed by Boston Dynamics, will now be patrolling the streets of New York. The mayor expressed his belief that deploying these robots could save lives and improve law enforcement efficiency. In a recent speech, Mayor Adams acknowledged that some activists oppose the idea but emphasized that his primary goal is to find the best solutions for the city, which led to the decision to move forward with the deployment. The NYPD's initial use of these robots in 2020 sparked public backlash, particularly when the Special Forces deployed Daiji Dog inside a building during a standoff with an armed suspect in 2021. In a recent speech, Mayor Adams acknowledged that some activists oppose the idea but emphasized that his primary goal is to find the best solutions for the city, which led to the decision to move forward with the deployment. The NYPD's initial use of these robots in 2020 sparked public backlash, particularly when the Special Forces deployed Daiji Dog inside a building during a standoff with an armed suspect in 2021. The robot was also used in incidents where intruders entered homes, but this led to further criticism due to privacy concerns. NVIDIA has unveiled a new software platform for the humanoid robots of tomorrow, called Isaac GR00T N1. This open and customizable AI model is designed to accelerate the development of robotic humanoids. At the GTC 2025 event, the company demonstrated the Fourier GR1 humanoid robot, showcasing its ability to perform a variety of complex tasks, made possible by the N1 model after post-training. With Isaac GR00T N1, robots can now learn intricate tasks much more rapidly, simplifying their integration into various projects. NVIDIA explains that the slow thinking system of GR00T N1 enables the robot to perceive and reason about its environment and instructions, allowing it to plan the appropriate actions. Meanwhile, the fast thinking system converts these planned steps into precise robotic movements, including multi-step object manipulation. According to NVIDIA, the future of humanoid robots lies in their adaptability and learning capabilities. The Isaac GR00T N1 model represents a major leap forward in robotic reasoning and skill development. Sanctuary AI's groundbreaking humanoid robot, Phoenix, takes center stage at a Magna manufacturing facility, marking a pivotal moment in the integration of humanoid robotics into car assembly and production. Magna, renowned for assembling vehicles for prestigious brands like Mercedes, Jaguar, and BMW, is a leader in the automotive industry. The introduction of Phoenix signifies more than just robotic assistance; it represents a bold step forward in efficiency and innovation. While specific details about the number of robots and their deployment remain confidential, this collaboration hints at an exciting future in advanced manufacturing. In May 2023, Sanctuary AI unveiled Phoenix, hailed as the world's first humanoid general-purpose robot powered by carbon, an advanced AI control system recognized as the only general-purpose robot in its class. Phoenix was also featured in Time's Best Inventions of 2023. Phoenix leverages cutting-edge AI to perform a wide range of tasks, from object manipulation to organization. With full-body mobility and human-like hands, it represents a major advancement in robotics, offering unmatched versatility across various workplace scenarios. Standing 5 feet 7 inches tall and weighing 155 pounds, Phoenix combines human-like characteristics with impressive capabilities, such as a maximum payload of 55 pounds and a top speed of 3 miles per hour. Its state-of-the-art robotic hands feature 20 degrees of freedom, providing precision and dexterity comparable to human hands. Enhanced by proprietary haptic technology for tactile feedback, Phoenix offers an intuitive and responsive experience. The robot's refined design combines sleek aesthetics with functionality, seamlessly blending performance with visual appeal. Its state-of-the-art robotic hands feature 20 degrees of freedom, providing precision and dexterity comparable to human hands. Enhanced by proprietary haptic technology for tactile feedback, Phoenix offers an intuitive and responsive experience. The robot's refined design combines sleek aesthetics with functionality, seamlessly blending performance with visual appeal. With capabilities like deep learning and reinforcement learning, Carbon equips humanoid robots like Phoenix to thrive in diverse environments, ensuring adaptable and efficient performance. Sanctuary AI's introduction of Phoenix in May 2023 marks a groundbreaking milestone in robotics, presenting a revolutionary humanoid robot powered by Carbon and an innovative AI system. Phoenix is the embodiment of the future of robotics, poised to transform workplace dynamics across a wide range of industries. At the recent ZC 2025 forum focused on artificial intelligence, robotics, and advanced technologies, Jalbert Robotics showcased the impressive capabilities of its robot, Jalbert G1. During the demonstration, G1 served drinks to customers, efficiently packed goods into boxes, and sorted products in a warehouse. These skills highlight the robot's potential to fully replace humans in routine jobs in the near future. At the recent ZC 2025 forum focused on artificial intelligence, robotics, and advanced technologies, Jalbert Robotics showcased the impressive capabilities of its robot, Jalbert G1. During the demonstration, G1 served drinks to customers, efficiently packed goods into boxes, and sorted products in a warehouse. These skills highlight the robot's potential to fully replace humans in routine jobs in the near future. So, what's the takeaway? Robots in these unlikely industries aren't just about replacing jobs, they're about redefining them. They're unlocking efficiencies, like faster workflows and personalized services, while letting humans focus on what we do best: creativity, empathy, and innovation. But it's not all rosy. We'll need to rethink education, reskill workers, and address ethical questions about automation. The future of work is a balancing act, and robots are at the heart of it. What do you think about robots in these surprising roles? Are you excited, or does it feel a bit unsettling? Drop your thoughts in the comments below, and let's get the conversation going. If you enjoyed this glimpse into the future, smash that like button, subscribe, and hit the bell so you don't miss our next deep dive. Thanks for watching, and we'll see you in the next one.